Hello engineers, welcome back to another awesome engineering session. I'm very excited today to teach you all about gears, okay? Now you might look at this and think that it is a wheel, okay, similar to this piece right here. And while this can work as a wheel, right, it can roll, okay, and you could attach this using an axle, and right, remember a wheel and axle is another one of our simple machines. So you could attach this to an axle and you could make a car out of it, okay? But when you look closely and when you feel it, you'll notice that the outside of this wheel is not smooth like most wheels are. The outside of this wheel, okay, has all of these little ridges on them, okay? And the engineering term for each one of these tiny little grooves, okay, is called a tooth. Okay, these are the teeth of the gears. Okay, engineers? Now, gears are super cool because they power lots and lots of things that we use every day. Okay, an obvious one is that gears are in cars that your parents drive. Okay, and the gears are what help control just how fast or slow your car can go. Okay, the brakes are going to slow your parents' car down, but the gears are what decides how fast the car goes when you push the pedal. Okay, we can talk about that in just a little bit. Now, the cool thing about gears, okay, is that you can have gears in different sizes, but as long as those grooves, which remember are called teeth, as long as those teeth are the same size as each other, then these gears can work together, okay? And when one gear spins, it's automatically going to make the other gear spin with it, okay? And when you connect multiple gears together, that is called a gear train, okay? Engineers, gear train. So today we get to help our builder friends, okay, make an awesome toy that you can play with using gears. And we're also gonna see if we can make a ride that our minifigure friends can spin on using gears, okay? Roller coasters in real life, roller coasters use gears. Any watch or clock, okay, that has a minute or hour hand that slowly goes around a circle, those are going to use gears, okay? And think about a wristwatch, a really tiny wristwatch, okay, that has gears inside of it. Those gears can be super, super tiny, okay? This is our smallest gear that we have with our kits, okay? But there are some gears so tiny that you need tweezers and a microscope to be able to place them in the right spot, okay? If you have a watch or if your mom or dad have a watch, there can be up to 5 or 10 gears inside of that watch. So think about how tiny they have to be to fit, okay? Now, like I said, the teeth on the gears, as long as they're the same size, then they can work together, okay? And I like to remember teeth because I think about the teeth in our mouth, and when we chomp down and our teeth fit perfectly together, that's how we can chew food, okay? So the teeth on our gears are gonna work together to make some awesome projects today. All right, engineers? Now, I just wanna show you how we can put these gears into our bricks, okay? We can attach them to an axle, okay? And then they can fit perfectly into one of these holes, and then there's enough room to make them spin, okay? So you can test out for a little bit. You can test out connecting different gears together. Okay, you can see how long you can make one gear train, okay, just on one of our bricks. And remember that if the teeth are not touching, okay, then you can spin one gear, but it's not going to spin that other one. The gear train is only activated when the teeth are touching. And like I said, you can connect gears of all different sizes next to each other. And the only thing that matters is that the teeth are the same size. So theoretically, you could have a gear that's as big and tall as this entire classroom, okay? And then you could connect it to one of these tiny little gears right here, as long as the teeth on the super big gear were small enough to connect to this one. Now, engineers classify, okay, different gear sizes by talking about how many teeth they have. So if you were in an engineering room, okay, and they were talking about these different gears, they would call this one the 40 tooth gear because it has 40 teeth. Now you can either count all the way around, or a good shortcut, okay, is we can use some multiplication. We can pretend that this is a pizza and that there's 4 slices, on the pizza. And this slice right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if one slice has 10 gears, then we'd say 10, 20, 30, 40. Okay, so we know this one has 40 teeth on it. Okay, this tiny, tiny one has 8 teeth. Okay, and I want you to work with your partner to count this medium-sized one to see how many teeth it has. Okay, and we can connect all those together, and when we spin one, it automatically activates all of them. Gears are such a cool, simple machine because they make so many projects work, and they are very efficient, okay? Remember, efficient means that we only have to input the energy of spinning one gear with our fingers, and all of these other gears spin automatically. Now, another engineering term, okay, that we're going to learn today is the difference between a driver gear and a driven gear. Okay, engineers? Now, the driver gear is the gear that the energy or the force is attached to. Okay, so in this example, this one is our driver gear, since that's one I'm spinning with my fingers, and all three of these are the driven gears because they're being driven by this one. Okay, and obviously we can switch which one is the driver gear, and you can tell that when we switch which one is the driver gear, that it changes the speed that the whole gear train moves. Okay, so if we spin this one, if this big one is our driver gear or this big one is our driver gear, the speeds are going to be similar. Okay, and if we spin our medium gear, the speed's going to be a little bit slower. And if we spin our small gear, the speed is going to be the slowest, okay? So you can manipulate how fast you want something to go based on which one is the driver gear. And that is how your parents' cars work, okay? Is that it has all of these gears inside of their car. And when your car is going slow, like maybe 10 to 20 miles an hour when you're driving in a parking lot, then it would have the smallest gear as the driver gear. Okay, and then once you start to go a little bit faster, maybe 40 miles an hour, okay, on some bigger roads, then the medium gear would be the driver gear as the car needs to go faster. And then once you got on the highway and you need to go really, really fast, 70 miles an hour, then the car switches to the biggest gear, being the driver gear. Okay, engineers, so gears are super cool because we can connect different sizes and manipulate speed and force just by choosing which one is the driver gear. Okay, engineers? Now, do you want to see what cool toy we can build for our engineering friends using gears? Okay, I do too. All right, so I'm going to take all these gears out. Okay, and what I'm going to do is I'm going to take our longest axle in your kit. Okay, and we're going to put that right into the middle of our 40-tooth gear. Okay, there are lots of holes on this gear, but we want ours right in the middle. And if you put it in the wrong hole, you notice that you can spin it and the gear won't spin. But when we put it in the right one, when we spin the axle, it automatically spins it. Okay, so I'm going to take my longest axle, my biggest gear, I'm going to put it right in the middle hole. Okay, and then I'm going to slide our lock piece on so that when I move my hand, right now it falls out. We do not want it to fall out. We want it to be secure, so we're going to use our lock piece. Okay, engineers? Now, give it a spin and make sure it's spinning good. If it's pushed on too tight, it might spin a little bit slower, so it's okay if it has just a little bit of room, okay, between the lock and the brick. There we go. We're going to set that piece down, and then we're going to take a 5-long axle. Now, when I say 5-long axle, okay, you'll notice that there's different gray axles in this kit. So when I say 5 long, what I mean by that is that it is 5 dots long. When we put it next to the dots on top of a brick, there are 5. It is equal to 5 dots long. Okay, engineers? I'm going to take my 5 axle. I'm going to put our medium gear on our axle, and I'm going to put our smallest gear on the axle. And then what I'm going to do next, okay, sorry, engineering friends, there we go. Now, when I'm going to put this axle right next to our biggest 40-tooth gear so that they're connected, so our medium gear is connected to the 40-tooth gear. okay? And then I'm gonna give it a spin, make sure that they're connected. Okay, what I'm gonna do is I'm going to flip it over, and I'm gonna keep my hand in place right there so it doesn't fall out. We don't want the lock on this one, but we don't want it to fall out just yet. And then I'm gonna set it on the ground. I'm gonna pinch my axle with my 2 fingers. I'm gonna give it a spin. And it's spinning pretty good. Okay, I'm gonna move our engineering friend to try it on the table here. Hope it doesn't fall off. Ready, 1, 2, 3. Nice. Engineers, we just built a spin top launcher. You just built a spin top launcher using the power of gears. How cool is that, okay? Now, question for you. What happens if we take another one of our big gears, we slide it onto our gray axle, okay? And then we connect it next to our other big gear, right? We can flip it over to make sure it's spinning properly. Looks good. I'm gonna flip this over, okay? Now, when we do this one, okay, I want you to count and see how long it spins for before it falls, okay? Ready? That was about 7 seconds. That's pretty good, right? I'm gonna try it on here. You can try it on the lid of yours also if it's falling off the table. Okay, that's pretty good. Okay, but what happens if we flip it over and we connect our smallest gear to our big gear like this? You think it's gonna spin faster or slower? Okay, I want to hear your guess. Okay, engineers, what do you think? Faster or slower? Is it going to spin for longer before it falls or shorter? Ready? Let's see. Whoa. That was way longer, right? Now, how is it that a smaller gear makes it spin for longer? The smaller gear made it spin longer than the biggest gear. How does that work? Well, engineers, the cool thing about gears is that bigger does not always mean faster, okay? Because when you're building a gear train, okay, if you want to go as fast as possible, what you do is you have the biggest gear that you have be the gear that the force is connected to. What was the name of that again? The driver gear, that's right. Okay, so you have our biggest gear as our driver gear and the smallest gear you can find as the driven gear, that's right. Okay, so we have our engineers, now that is how you can use gears, not only to make a spin top launcher, but make the spin top launcher as fast and as powerful as possible, okay? Now, remember I said that we can make really efficient projects using gears, meaning that we can spin 1 gear, right? And in this case, we're making 3 gears all spin together on this axle, okay? But is there a way to actually double the efficiency of this spin top launcher? Meaning, is there a way that we can launch 2 spin tops at once? Nice, I see some of you have the right idea. Okay, so we can take another axle. We'll take another 5 axle. We'll put our big gear on it, our little gear, our medium gear. And where am I gonna put it? Yes, right on the other side of our driven gear, right? Perfect. Now you notice that I put this one, the big gear, on the top, and this one I put the big gear on the middle. The reason I did that is because I wanted to see if it would make a difference, okay, between how long they would spin for if we had the biggest gear here or there. So now I'm gonna hold them both in place with my hands, flip it over, give it a spin, and we have just made a double spin top launcher, engineers. That is awesome. Nice work. Okay, now I want you to launch it. I want you to see the longest I've gotten my spin top launcher to spin for is 30 seconds. Okay, I want you to see if you can build yours for even or make your spin for even longer. Now a bonus challenge, okay, after you get your spin top launcher working, is I like to set up our minifigures and I like to spin the launcher, launch the spin tops, I should say. Okay, and then I like to see if you can make it accurate, if you can try to make it knock over our minifigure friends. Okay, and it's tricky, but with some practice, you can get pretty good at it. Okay, and you can also try to move the spin top launcher, move the spin top by blowing on it. Okay, you can actually control, you can help control which direction it goes by blowing on it, okay? Because they're small enough that the force from your breath can actually help move it just like wind, okay, engineers? Now, after you've built that, after you've tested it, after you've played with it, after you've battled it with your friends, if you would like to make a little arena out of Lego bricks, okay, you can make a square rectangle out of Lego bricks, and you can both launch your spin tops at the same time and see which one lasts longer, okay? I want to talk about one more thing with gears. Now, so far, with our gears, they've all been spinning in the same direction, okay? Right? So they have to connect. They all have to connect, there we go. They all have to connect, right, going in the same direction, okay? So if this one is spinning like this, then that means that this one and this one also have to be spinning, okay, in those same directions. But is there a way to make it so that we can spin this way, but we can have something spinning perpendicular to it, okay? What that means is that it's spinning in the opposite direction. These are all parallel. These are all next to each other, spinning in the same directions. I want to make something that's perpendicular, that can spin like this. For example, if we wanted to make, okay, a ride that our engineering friends could stand on and have it spin in this direction, right? Have them spin like this, even though the gears are spinning like this, okay? Now, there's a very cool way to do that, and it requires a special type of gear. This one right here. Okay, you can grab it out of your kit. You can put it right next to this one, and notice that they're the same size, and they have the same amount of, what are these called again? Teeth, that's right. But these teeth are different than these ones, okay? When you feel them, you'll notice, okay, that these are almost a little bit pokey. Okay, and this one, if you have it this way or you flip it this way, there's not really a difference. This one, you flip it this way or this way, there's a big difference, right? Now, this gear right here, engineers, is called a crown gear. And the reason it's called a crown gear is because if you have it facing up, right, with the pointy parts facing up, it almost looks like a crown, right? So that's why that's called a crown gear. Now, here's what we're going to do. There we go. Here's what we're going to do to make our crown gear spin a ride that our minifigure friends can stand on, okay? It's really cool, engineers. So what we're going to do is we're going to take a three-hole brick like this, excuse me, okay? And we're going to stick a black axle. Okay, this black axle is 6 dots long. We're going to stick a black axle through the middle of that red brick. Okay, so it should be just like that. Then, on top of that, we're going to put a 5-hole flat white brick like this. Okay. And then we are going to make sure that we don't want this axle to slide at all. So we're going to put on, that's right, a lock piece to help lock it in place. Then we're going to take 2 of our yellow 1-hole bricks, one right there, one right there. Should put that on the white brick first. There we go, like that. We're going to put this right here. So this is what ours should look like. Okay, engineers? And then we're going to take our longest gray axle, which is 7 dots long. We're going to slide that crown gear with the pointy ends facing down, okay? And we're going to put it, oops, there we go. We're going to have it like that, okay? And then I'm going to take another one of those flat white bricks and put it right on top like that. And then we can see if our medium-sized gear and our crown gear are connected. Ooh, and they definitely are. Okay, so you can see how this gear is spinning this way and the crown gear is spinning this way. We have connected two gears that are perpendicular to each other. Then we're going to take, oops, that one's a little too tight. There we go. Our yellow circle like this. We're going to put it right on top like that. We can put our minifigure friend, our engineering friend on top like that. I like to connect this whole thing onto a sturdy foundation. Set him down and give him a spin, engineers. That is how, and which one is our driver gear? Our crown gear or our medium one? Which one's the driver gear? That's right, the medium one is the driver gear and the crown gear is the driven gear because the medium gear is the one getting the force from our fingers. Engineers, congratulations, you just built an awesome spin top launcher and an awesome ride for our engineering friends, all using the power of gears. Engineers, fantastic job building today. Thanks for all your hard work, and we cannot wait to show you some more simple machines next week.